And in today's episode, among other things, you'll see that China shocked the world with the presentation of humanoid robots marching in perfect sync over there in Beijing. The United States is taking that idea of humanoid robots patrolling the border with Mexico seriously. A startup has created a robotic horse that is capable of transporting people and even other robots. A new MIT controller allows you to operate excavators using the natural movements of your arms. China has created a new tunneling machine that drills into the ground and uses explosives against solid rocks. Well, my friends, let's break down all this and a few other new tech stories. Hello, impressed viewers. I'm Carlos Alves, and you're watching Incredible Reality. 80 humanoid robots marching in perfect synchronization during the opening ceremony of the 2026 Humanoid Robot World Games held in Beijing, China. These machines in the video are the Booster T2 model, developed by the Chinese company Booster Robotics, and recently introduced as their new platform for research and development in embodied artificial intelligence. Well, the T2 is about 1.40 meters tall and weighs around 43 kilograms with 31 degrees of freedom. 12 of them are concentrated in the hands, allowing for more precise movements during those manipulation tasks that we see robots doing out there. The robot also uses 2 sets of binocular cameras, positioned on the head and in the waist area. This setup allows it to keep track of its surroundings, while another system maintains a closer view of the area where the hands are working. But one of the main changes compared to the previous generation is in processing capability. In the T2 Pro version, Booster uses the NVIDIA Jetson Tor platform, which can provide up to 2,070 teraflops of computational power to run artificial intelligence models directly on the robot. This local processing is very important for embodied artificial intelligence applications, where perception, decision-making, and movements need to happen continuously. In practice, the robot can observe the environment, interpret a situation, and turn that information into commands for its joints with less dependence on the cloud. Booster developed the T2 mainly as an open platform for researchers and companies. At the Beijing Humanoid Robot Olympics, this capability was also tested in a different activity than the walking demonstration at the opening. There, the Booster T2 was used as a platform in 7-on-7 humanoid soccer, where 2 teams compete in matches autonomously, meaning without human operators controlling each robot individually. In this scenario, the robots need to identify the ball, locate other players, navigate the field, and decide when to run, pass, or kick. I want to know when these guys turn into little cars. I want to see that. Therefore, soccer works as a test for problems that also appear outside of sports. A humanoid robot needs to perceive moving objects, avoid collisions, maintain balance, and modify its actions as the environment changes. These are very similar abilities to those needed for these machines to eventually work in factories, logistics centers, and other environments originally designed for us human beings. This presentation with 80 units of the Booster T2 robot showed another possibility: operating a large number of humanoid robots simultaneously in the same space. Imagine an army there, huh? Something that unfortunately could become more and more common as these machines keep evolving, you know? And engineers at MIT in the United States have developed a new control interface for excavators that can drastically reduce the time needed to learn how to operate these machines. The operator, in a simple way, holds the mechanism and moves their own arm, the same way they would when operating an excavator. By extending the arm, rotating it, or making a grabbing motion, the system interprets these gestures and turns them into the corresponding commands for the excavator. This proposal tries to solve one of the main difficulties faced by new operators. In conventional excavators, the movements made on the joysticks do not directly correspond to the movement the person wants to perform in the environment. The operator must learn which combinations control the rotation of the cab, boom, arm, and each machine component. Over time, experienced professionals develop a mental model that allows them to coordinate all these movements almost automatically. But acquiring this skill can take years of practice. Beginner volunteers and experienced operators were trained for 1 hour a day over 7 days. When they used the conventional joystick controls, the beginners performed much worse than the professionals, which is obvious, right? Beginners performed much worse than the professionals. But with the World Space Interface, the name of this technology, the result was very different. The beginner operators were able to achieve performance very similar to the experts already in the first session. The researchers believe that the technology can also be used outside of simulators. A version of the system could be installed directly inside the cabin of an excavator, with the mechanical arm working almost like an amplified extension of the operator's arm. Another possibility would be to use the interface for teleoperation. In this case, a person could stay in a safe place while remotely controlling an excavator working in very dangerous areas, such as disaster zones, mines, or places at risk of collapse. Companies like Caterpillar, Hyundai, and Komatsu are also already working on simulators and remote operation technologies for these heavy machines. However, most of these systems still use joystick-based controls. The approach developed by MIT takes a slightly different approach, right? Making the machine directly interpret the movements that humans already make naturally. And China has presented what we call here the Tatu Zone, a new excavation machine designed to tackle one of the main problems encountered during tunnel construction: unexpected changes in the geology of the terrain. This happens much more often than we think, you know? Called Shanglong, not Shailong, okay? Or Lucky Dragon. The machine combines two techniques in a single machine that are normally used separately. It can excavate the ground mechanically, like a conventional tunnel boring machine, and when it encounters tougher rock formations, it uses drilling and explosives to break up the rock before continuing to move forward. According to its developers, this is the first machine in the world that uses two methods in this way. The equipment was developed by China Real Sense and Industry Group in collaboration with Tsinghua University and came off the production line in Wuhan. The machine has a cutting head of approximately 4.5 meters in diameter and a hollow structure in its central region. Through this opening and other specific channels, drilling equipment can create deep holes directly in the rock formation in front of the machine, and these holes can then receive explosive charges. Before the detonation, the cutting head can partially retract, while the protection system absorbs the impacts and protects the sensors, mechanical components, and other precision parts that are installed behind it. The charges used are designed to produce fractures in the rock formation. After the explosion, the head returns to the working position and continues excavation, crushing and removing the previously fragmented rock. The system can also switch between different operating modes. Depending on the geology encountered, the machine can perform the first blast and then excavation. Or it can simply start excavation before using explosives, or work only with the conventional cutting head. It depends on the situation, of course. Other solutions have been incorporated to allow the equipment to adapt to the conditions encountered during the operation. Retractable side cutters allow the excavation profile to be modified, while a telescopic rear shield can adjust to different segments used in the tunnel lining. According to information released in China, tests indicated that the combination of the two techniques can increase excavation efficiency by approximately 30% compared to a conventional tunnel boring machine in complex geological conditions. And Dashi developed a machine designed to function as a kind of mechanical horse, a robot horse. Called QGX-1, the robot attracted attention during the World Robot Conference 2026 held in Beijing, where visitors could literally climb onto the robot's back and take a short ride with this machine. The project combines 4 independent robotic legs with a structure equipped with a saddle and handlebars. In practice, the user rides the QGX-1 in the same way they would ride a horse or a motorcycle, for example. The difference is that instead of wheels or muscles, movement depends on 4 mechanically and electronically controlled legs. And its dimensions are much larger than those found in most quadruped robots available today, these so-called robot dogs. According to the company, the QGX-1 can carry a load of up to 300 kilograms. This means it was not developed just to carry equipment, and it became quite clear that it has enough capacity to transport people. And in one of the most interesting demonstrations held in Beijing, even another robot, a humanoid robot, appeared riding on the robotic horse. That was really interesting to see. The machine was also designed to operate on surfaces other than perfectly flat ones, you know? Its 4 legs can adjust individually while the robot is moving, allowing it to cross uneven terrain and maintain stability while carrying the load on its own body. The QGX-1 reaches a maximum speed of about 10 kilometers per hour, which is far, of course, from making it a replacement for motorcycles. But speed doesn't seem to be the main goal here. The advantage of a machine like this is precisely being able to reach places where conventional vehicles start to have difficulties. A wheeled vehicle depends on a relatively continuous surface, but a legged robot can choose where to place each of its limbs. This opens up possibilities for crossing rocks, sloped terrain, trails, mud, and other surfaces where small wheels would have a lot of trouble. And the idea of building large quadruped machines big enough to carry humans is starting to show up in other projects as well, you know? Last year, we saw Kawasaki, for example, working on its own robotic horse concept called Corlu. It was originally introduced as a personal mobility machine capable of traversing difficult terrain. In this trade show scenario, at first a robotic horse might just seem like a curious demonstration, right? But a quadruped platform capable of carrying hundreds of kilos across terrain where traditional vehicles can't operate could find applications in agriculture, mining, equipment transport, rescue operations and logistics, warfare, and remote regions. The humanoid robot industry is starting to go in very different directions, and few companies show this as clearly as the Chinese company Engine AI. In just a few days, the company presented two completely different applications for its humanoid robot called T800. In one of them, it's working inside a factory. In the other, the robots are fighting each other in a ring in the United States. The first demonstration took place at a Luxshare CT factory located in Shoushou, China. Engine AI released an official video showing several T800 robots performing different industrial tasks inside a facility. According to the information presented in the video itself, the robots can receive work orders directly from the MES system used to manage production processes. After that, the vision system identifies the type.
Dos materiais que precisam ser manipulados.
The robots then use both arms to pick up and position these objects. The demonstration also shows T800 carrying a load with just its arms, and it does this by dynamically avoiding obstacles and performing full-body movements to position containers in a stable way. The choice of Luxshare for this demonstration is significant. The company is a leading Chinese electronics manufacturer and an Apple supplier. The presence of the T800 inside one of these facilities shows the manufacturer's intention to take robots from demonstrations to industrial applications. But the video also brings up some interesting questions, right? The presentation is highly produced and edited, you can tell. And Engine AI keeps indicating throughout the footage that the scenes were recorded right there on site. And clearly this happens after previous demonstrations by the company raised doubts about the possible use of computer graphics. In the case I'm referring to here, Engine AI even released behind-the-scenes footage to show that the movements performed by T800 were actually real. Remember the kick to their CEO? That's what happened there. Even so, in this new demonstration, the well-crafted editing makes it difficult to determine to what extent the robot is able to perform these tasks autonomously when it encounters situations that were not set up in advance. And the contrast becomes even greater when we look at what happened just a few days earlier. On August 15th, T800 made its physical debut in the United States during REK2. This is a humanoid robot combat event held in San Francisco. In this case, both T800s were controlled by human pilots and were put face-to-face in matches broadcast over the internet. This tournament ended with the victory of a Japanese pilot named Hiroyuki Ozone. Wow, that's a hard name to say. These two applications are part of a strategy that Engine AI itself has been developing for the T800. According to the company, the physical demands of the matches are used to test features such as structural resistance, dynamic balance, and joint torque. The T800 has an initial announced price of approximately $25,000, while the company says it is working to reach a delivery capacity in the tens of thousands still this year. And the United States Department of Homeland Security, the DHS, has started talking to robotics companies about the possibility of using humanoid robots in security operations at the border between the United States and Mexico. Among the companies that have already presented their technology to the US government is Foundation, the developer of the humanoid robot Phantom. They reported their idea is still in an early stage. The DHS itself states that currently it does not have any pilot project, agreement, or active contract with Foundation. But Sunkip Patak, the founder and CEO of the company, says that his team is already in talks not only with the DHS, but also with different robotics sectors of the US Armed Forces, including the Army, Navy, and Air Force. The goal would be to use the humanoid robots mainly for surveillance and reconnaissance tasks. The Phantom was developed to walk autonomously over uneven terrain, map its surroundings, and distinguish humans from other objects it encounters along the way. This would allow these machines to be sent to regions where ground vehicles, fixed towers, or even drones have limitations. At the border, for example, the robot could patrol a certain area, identify movements, and then send an alert to a human agent. The decision about what to do would still be made by a person. That's what they say. According to Patak, one of the main advantages would be precisely to keep agents away from potentially dangerous areas. The humanoid robots could continue conducting surveillance for long periods, while human teams would only be called in when some relevant activity was actually detected. Another environment considered by the company is the tunnels found along the border. Since humanoid robots have a form of locomotion similar to humans, the Foundation believes they could indeed enter certain spaces originally built for people and carry out reconnaissance there before human agents are sent to the location. But there's a pretty important problem here, you know? The current generation of the Phantom still hasn't been designed to continuously withstand the harsh conditions found in an operation like this. And prolonged exposure to the environment are still limitations. That's why the Foundation is developing a second-generation robot with greater durability and better protection against water and dust. TAC believes that a small test could indeed be carried out quickly there, and that larger operations could be considered in the coming months, you see. There's an even more controversial possibility here. Although the company's current focus is surveillance and reconnaissance, the executive stated that Foundation would be willing to develop armed versions of these humanoid robots if the US government requested that capability. Even so, he says that, at least in the near future, these robots wouldn't be responsible for automatically deciding when to use force. In other words, to take someone out, right? The machine would only detect a situation and send the information, and a human would still be responsible for the next decision. Drone swarms are creating an increasingly bigger problem for these modern air defense systems. Shooting down a single drone is relatively simple. The problem starts when dozens of them show up at the same time, and especially when each drone costs only a small fraction of the price of the missile used to destroy it. And now in the United States, Northrop Grumman has presented a rather different solution to this problem. Called Raid Hunter, the system combines artificial intelligence, a Bushmaster automatic cannon, and 50mm ammunition capable of correcting its own trajectory after being fired. Basically, it's a machine gun capable of piercing armored tanks, in the hands of an AI deciding when to shoot. That could never go wrong, right? Let me explain that there's irony here, some people might not get it. The system uses sensors connected to a defense network to monitor the airspace. A command and control system equipped with artificial intelligence processes this information and can identify and track multiple threats simultaneously. This includes small drones, in coordinated swarms, and even cruise missiles flying at low altitude. However, unlike a conventional cannon, the Raid Hunter doesn't just fire projectiles following a purely ballistic trajectory, okay? The ammunition used by the system has precision guidance. In practice, each projectile behaves almost like a small guided interceptor. If the drone is moving or tries to change its trajectory, the projectile can keep correcting its course as it approaches the cannon. For now, the Raid Hunter is still undergoing an accelerated testing campaign throughout 2026. Northrop Grumman states that they do intend to validate the system quickly so that it can be deployed in the very near future. If you like this episode, leave a like, check your subscription, and click one of the 2 suggestions on your screen. Just click, and I'll see you there. Thank you! Bye, see you soon! I'll be waiting. Click there!